Well, hello there, this is Satvik. I hope you guys are doing great. Welcome to my channel Witty Physics. So today we are going to discuss about the array data structure, which is one of the most basic data structure. Alright, I know you guys are a bit shaky because the name of my channel ends with physics, but trust me, I got your back. So yeah, enjoy the show.
First of all, kindly ignore the background noise. Due to some reasons, I had to record this video in the evening time, so please excuse me. All right. Before getting into any kind of discussion, I just need to ask you just one simple question. It might sound lame, but it got direct relation with arrays. All right. So the question is whether you have visited any company tagged under PSU. PSU as in public sector undertaking. These are the companies which share a percentage to Indian government. Well, if you have, then you must have noticed that these companies share a similar behavior when it comes to assigning houses to their employees. Well, first of all, they will segregate a particular land which is exclusively for livelihood of their employees, means to build houses for their employees and their families as well. So, yeah, this area is divided into three major sectors. First, worker. Second, officers. Third, higher official. Well, higher officials are the heavy hitters of the company. Heavy hitters as in the MD, ED, AGM, DGM, etc. So I won't be getting into that. So yeah, these are the three major sectors. Now, the catch is there is a constraint when it comes to assigning the houses to the people, I mean the employees, belongs to this particular post. So, what is that constraint? Well, this constraint is that you cannot assign an officer to a worker quarter or a worker to officer quarter. This also gets applicable when it comes to higher officials. So, this is the constraint which almost all PSU follows. Not almost, each and every PSU follows. So, the arrays behave exactly alike. How is that? Well, first let me clear this page. Well, array looks something like this. Yeah, this is array. Well, this array is first of all divided into smaller blocks, which are referred to as memory space. Alright, so these smaller blocks are called memory space. Now, these blocks got a subscript or a superscript digits on them. Well, what is that? Say 0, 1, 2, 3, 4, 5. These digits represent the address of this memory space. The note point is here that these digits are completely unique to each other. I mean to say distinct. So why is that? Because this represents the address. Means you can have repetition of elements inside an array, but the address won't get repeated. All right. So yeah. Now let's put some data into it. Means the elements into it. So A, B, C, D. These data are referred to as elements. Well, in order to declare an array, you have to previously define three things. First, of course, you have to declare array. Second, define the type of array. Means here it is character type. You can define it as integer type or string type. It's up to you. So yeah, define the type. Third, specify number of memory space. Means you have to previously define how many number of memory space you want in your array. Alright. So yeah, these three things you need to do in order to form an array. Now there are two constraints. First, as I mentioned in the PSU thing, that you cannot insert any other type of data into this particular array. Why is that? Because this array is previously defined as the character type. Just a second. So this is a character type array. Alright. So if you want to insert integer type of data, say 2 into it, you cannot do that. Well, first of all, it is completely full, so you obviously can do that. But say you have an array which got some empty spaces. Yeah. Say the whole array is empty and you have defined it as character type. So if you now uh, want to insert 2 inside it, you cannot do that. Why is that? Because 2 is not a character, 2 is an integer. Alright. In the same way, if you decide to declare an array which is of integer type, then if you want to insert a character into it or a string into it, then obviously you can do that because this is not an integer. So yeah, this is constraint number 1. Well, what is the second constraint? Second constraint is that um, if an array is full, then you cannot insert any further elements into it. Say you got an integer type array. This is an integer type array. So first of all, give the address. Say you have previously got two elements, say 6, 7. Now you want to insert another element which is 4, let's say. So you can easily do that because there are a lot of empty space in this. So 4 gets inserted. Then say 5, cool. Then say 8. It will also welcome it because there is one space left. So 8 gets inserted. Now if you want to insert another element, say 10, then you cannot do that because there is no memory space left to do that. So well, there is a method in which we can expand the memory of an array, but for now you just need to know that if an array is completely full, then you cannot insert another element into it. Alright, so yeah, now let's see the syntax of declaration of array. Well, before that I just want to make clear myself that the programming language I'm going to use is Java. Use any other programming language if you wish to. You just have to Google for the syntax of declaration. Well, the concept behind them are completely alike, so you got nothing to worry about. Yeah. Let's move to the declaration part.
Declaration of array. Let's say you are going to declare an integer type of array. So int followed by empty square bracket. After that, name of the array. Well, I'm going to give the name as numbers. Well, it's up to you, whatever you like you can give. So numbers equals to new int. Here inside this braces you have to specify the number of memory space you want in your array. Let's say 3. So after writing this statement, you will find that well, you cannot find, your system will form an array which looks something like this. So this is the array 0, 1, 2, and it will also initialize it with zeros inside the memory space. Well, by default it puts 0 inside them, but if you want to insert any element of your choice, you can do that. It will just replace it and place your element instead. So yeah, this is how you declare an array of integer type. In order to form an array of character type, you have to just write char instead of integers. So same goes with string type. All right, so yeah, this is the declaration. Now how to insert elements in an array. So in order to do that, you got two methods. All right, first we will discuss method 1, which is the lengthy one. Well, both of them got their own utility, so you need to know both of them. All right, so method 1, numbers of 0. Well, this 0 is the address of the memory space in which you want to store this element. Let's say 10. All right, so the system will just replace 0 and instead put your element, which is 10. Then say numbers of 1 as 20 and numbers of 2 as 30. So this is 20 and this is 30. There you go. So this is how you insert elements. Well, there is a second method which is much more easier one, method 2. If you know the elements beforehand, then you can directly declare them, insert them at the time of declaration. All right, so how to do that? Well, int numbers, that's equals to, directly place your elements inside parenthesis, which is curly brackets. So 10, 20, 30. So just by writing this means this line, your system will form an array with 3 memory space, because it will just count how many elements are there. So it will form 3 small blocks and 0, 1, 2, 3, and place the elements starting with the first as the 0th, first in the 0 address, then followed by 20, 30. All right, so yeah, these are the two methods. If you don't know how many elements you are going to store inside an array, or what are the elements you are going to store in them, then the method 1 is applicable. All right, and if you previously know what are the elements you want to store in an array, then you can directly go for method 2. So yeah, this is how you declare array. So now let's see the time complexity of some basic operations in array. All right, so let me just clear these things.
Something like this. Alright. So these are the memory space, address, now elements. So this is your array. Now we need to find the time complexity of some basic operations. Number 1, lookup. Lookup as in, let's say you need to find what is inside the address 3. This is the address, and you want to see what is inside it. Alright, so if you want to do that, then the pointer of your system will directly go to the address 3 and return whatever there is inside it. So the time complexity is O of 1. Now let's say you don't know the address. Means you want to find the element D, but you don't know the address of that element. So in order to do that, the pointer will first go to the address 0 and check whether D is inside or not. If not, then it will move to the next address, which is 1, and check whether D is inside or not. So nope, it's not here. So then second one, third one, fourth one, and here in memory address, the address 3, it encounters D. So it will return either 3 or true. Why it will return 3? Because let's say you want the address of that particular element, so it will return the address. Or if you want to check whether that element exists in the array or not, then it will return true. Let's say you want to look for an element which is not inside it, say G. Well, first of all, the pointer will go to the 0, then G is not there, so it will move to 1, then 2, then 3, then 4, then 5. Uh, well, 5 is the last memory space, so it didn't encounter G here, so it will return you -1, which represents that G is not there inside your array. Alright, so in order to do that, it had to traverse the whole array. Are you getting it? So the worst case, when you don't know the address of that element and your element lies something somewhere at the end, or it doesn't lie inside your array only, then the time complexity becomes O of n. So this is for the lookup. Then comes resize. Um, let's say you have an array which is completely full. Well, you have an array which is completely full, and you want to insert another element, let's say G, into it. So in order to do that, you have to first declare a new array which got more number of memory spaces uh, than your previous one, at least one more, because you need to insert just one element. So yeah, it is not advisable to increase your array size by one, but it's up to you. Yeah, all right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your new array. Well, now you have to copy the elements of the older one into the new one into their respective memory spaces. Memory address. Let's say 0, inside the 0, A is there. So here inside 0, A. In 1, B. So B, C, D, E, F. Alright. So yeah, now you got all the elements from the older one, and you got some space, empty space as well. So G gets into it. G. So yeah, as simple as that. Well, it looks simple because we have declared a small array, but if there is a very huge array, means a large one, then it might become a little bit time consuming. So anyways, the time complexity of doing this is O of n. Well, we don't have to insert an element in order to resize it. We can just generally resize it, and the complexity of doing that will be O of n only. So yeah, this is resize. Now insertion. Well, I just said you the worst case possible, means if the address, I mean the array is completely full, then you have to resize it, then insert that element. So the time complexity will be O of n. This n is for resizing plus 1, which is for inserting. So this is almost equals to O of n. Well, this is the worst case. Now the best one is that you have an array which is not full, means it got some empty spaces in them. So if we see, and this is empty space. So you want to insert element D. So it don't have to do anything, it just goes into the empty space. So the time complexity of doing that is O of 1. Sorry, O of 1. This is the best case. Alright. So that's it for today. In the next session, we are going to discuss about the array list or the dynamic array. Well, we are not going to just discuss it. We are going to build our independent dynamic array and also look into the deleting stuff. Alright, means how to delete an element in an array and what is the time complexity of doing that. So yeah, till then, have a good day. See ya.